Hey, time for your life's math and history, and we are going to take a look at graphing transformed sine and cosine waves. So in the past few videos, we've been learning about how to understand what the sine waves and the cosine waves are. At first, we've learned about this equation that we've learned in Algebra 2 and previous units. We've also been understanding that this looks like a cosine wave right here, and this right here looks like a sine wave. They're totally different. One is having the top intersected at the 0 point, the other one in the middle. So we've been learning about those in the previous videos, and we've also realized that this formula right here had to be upgraded for pre-calculus. Yeah, we had to use these kind of formulas. So they add a b into the formula as well as a trigonomic function. So what we're going to do is we're going to simplify this formula. So instead of memorizing, we're trying to put this in action. But what does A, F, B, X, C, D mean? Well, since we are talking about graphing and transforming the sine and the cosine waves, then here is what it looks like. The A represents your scale factor, which represents the troughs and the tops, meaning how tall the amplitudes are going to be or how wide they are. The F is simply the function that you put inside. The B represents the period and the frequency. How many times, how far on the x-axis you will go when you make one full rotation. The x minus c talks about the space shift, which we'll talk about in the next video. And D is the easiest one to understand and memorize, which means you move the entire thing up or down. So since we know what these things are, let's try to put this in action. So yeah, ready, lights, camera, action. So right over here is a problem that we're going to graph. Instead of trying to understand A, B, C, D, blah, 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 we're going to actually do the math and make it very, very simple. So right here, we have the f of x equals 2 cosine 1/4 x in parentheses. So here's what happens. In the previous video, we've learned about the amplitude and the period. So we're going to try to find the A and the P before we start graphing. So we know that amplitude is the easiest because that is going to be the number 2, which literally means the scale factor right here. So the number 2 is going to go right here. This means that on the y-axis, we're going to mark a 2 and a -2 for a reference. But what about the period? Well, we said earlier that the period is how far on the x-axis will you go until you make one full rotation, or when you get back to where you began in the first place. We know that on any kind of wave, whether it's sine or cosine, we know that a period is always going to be from here, it goes up, then down, then back to where we are. Same with this one. It goes down and up back to where we are. So what we gotta do is find out the period of the function. So right here, we don't have any direct detail, but we do gotta use a formula. The formula is, I'm gonna put it down here, 2 pi divided by b. The b represents the period, which explains why this equation right here has a b right up here, the period and the frequency. So we have 2 pi divided by b, and turns out that our so-called b right after the function is 1/4x. So we're gonna do 2 pi divide that by 1/4. That's because the 1/4 represents the b value. But the problem is, this doesn't seem like a normal answer you would see in a math problem. You can't divide by 3 numbers without rearranging it. So what we can do is multiply by the reciprocal of 4 over 1 and 4 over 1. So in reality, the problem is now 2 pi multiplied by 4, which means it's going to be represented as 8 pi. So our period is going to be 8 pi right here. Hey, guess what? Since we know that the amplitude is going to be 2 for the cosine wave, and the 8 is going to be the period, that will drive us to our final answer by putting out, or drawing up the 5 different coordinates. So we have 8 pi right here, we have 6 pi right here, 4 pi, 2 pi, and 0. And we know the amplitude is 2 and 2. So here's what happens. The cosine is going to be positive. So right over here is an example of a cosine wave. It goes from the amplitude down, then back up. And since it's going to be 1 over 4, that means the graph right over here is going to start at the amplitude. It's going to go down 2 pi, going to go under 4 pi, then back up to where it stops. It goes from here, back down, then back up. The wave has to intersect the x-axis twice for it to work. So you stop right here, and boom, we are done with this problem. We don't have to do anything else. This is totally graphed. So let's try to solve one more problem and see how it goes. So right here we have the g of x equals negative 2 sine x plus 5. So before we start anything, we have to think about the number 5. But why the number 5? Well, the number 5 represents you move the entire thing up or down. So in reality, we are going to move the entire thing up. So this horizontal line is not 0. Instead, it represents the number 5 on the y-axis. Now let's take a look at the amplitude. So we have the amplitude, and we have 2. Remember, the amplitude is always going to be positive because it goes 2 units up and 2 units down. You can't have negative vectors, and you really can't, in terms of geometry and trigonometry, you can't really do that. So for the period, we have to think for a moment. Well, we don't have anything but x as the period, so we can just go ahead and say that our period is going to be 2 pi. Okay, let's start graphing. We have 2 right here and negative 2 right here. We are going to have 2 pi right here, 3 pi divided by 2. We're going to have pi, and then pi divided by 2. And eventually 0, which starts right here. But there is one question. We know that the sine wave is definitely going to look like this. Or is it? That's because if you look at the formula, well, not the formula, if you take a look at the equation, you notice that right in front of the 2 sine, there is a negative sign right over here. There's actually a negative sign, which is going to affect the entire thing. Right there. So what's going to happen is, instead of making it look like a positive sine wave, just like this one, it's going to flip. Not exactly like that, but here's what happens. Right over here, we have a picture of different graphs. So normally, it does make sense that a sine wave is going to go down, then up, then down. But a negative sign is going to go up, down, up. For a cosine wave, it's going to go from up, down, up. Then a negative cosine is down, up, down. And the crazy thing is that a positive sign and a cosine that's negative, in terms of having the exact same trig ratio when x is just by itself, is going to be the same. The same thing goes with the sine negative and the cosine positive. It's just like assuming in your math class you are sitting with your partner on the other side of the room. If you say, I will point to my right, and I point to my right, but your partner points to their left is the same as saying your right. So you guys are literally pointing in the same direction, towards the smart board or the whiteboard in front of your math class. So right over here, this is not going to be a normal sine wave. Instead, it's going to be negative. So it's going to start. So what we're going to do is we're going to start right here. And then we're going to go down under pi divided by 2. Then we're going to go right back up to pi. Then go up. Then go and finish at 2 pi. So that is what the graph is going to look like. And the other part is this is a lot more harder to do since we have a reflective one. And it's a good idea to kind of understand the sines and the cosines and the directions if they're reflected or not. So right over here, I made a revised table showing the directions for the sine and the cosines, whether they're positive or negative. But what I did here is I put the sine waves where halfway they are having the center touch at the halfway mark. For the cosines, I had the tops and the bottoms touch the y-axis. So there's less confusion. So this example is an easy, simplified way to understand how to graph the transform sine and cosine waves. I hope this video has helped you understand how to graph the transform sine and cosine waves. Thank you for watching Taoping Airlines Math Industry. Like and subscribe.